So before the break, we just went over basically using the exponent rules, right? Exponent laws to solve equations. Okay, now we are going to look at the function. Okay, how exponents can also be graphed. So in transformation, if you remember, we talked about the 6 basic graph, right? That we could apply the RST on, right? So for example, like parabola, right? Cubic, radicals, right? Different kinds of function. And exponential function was one of them, okay? So we need to know their basic function, their basic shape. Then we can apply the reflection or translation to them, okay? So for all the exponential function, they all have this look, right? The equation, they will always have a base, right? And then also exponent is the x, which means it's the input, right? So if I sub in 2, right, and then you can get a number out, right? Then that number, the number that you get is the y value. So you have input, output, so that's x and y. Then you can graph it, okay? So the function can be graphed differently, right? The shape will look different depending on the value of the base. So here it divides into 2 kinds. One is when the base is bigger than 1, right? The first kind. The other one is when the base between 0 and 1, okay? So you can write that down, okay? Base between 0 and 1. So does not equal to 0, does not equal to 1, okay? The other one is base greater than 1. Okay, so 2 kinds. So we'll graph them out, okay? We'll use an example to actually graph it and then see the pattern, okay? And how do we define them, okay? How they look differently. So the first example I have here, I will highlight it here, right, is y equal to 2 to the x. So the base is 2, right? That's greater than 1. The second one, I use the 1/2, right? Y equal half to the x. So half is between 0 and 1. So anything that's the same kind, right? Anything that's has a base greater than 1, they will look similar, okay? Even though tiny little difference, but the direction that it goes will be similar. So we are going to use some basic points that we've been using all the time, okay? -2, -1, 0, 1, 2, okay? So can you plug them into the x and then find the y value, okay? Once you finish the table, please raise your hand, okay? Plug in the x and get the y value. All right, let's check the points that you have, okay? If you already got the table, you can start plotting the points. Okay, Donna, what are your y value? Have you got them?
Wait, no. 1/4, 1/2, 1, 2, 4.
Yeah, very good. Okay, negative exponents will turn it into a fraction. Okay, so let's plot them. So just follow the points. Negative 2 is 1/4. So 1/4 is really tiny, right? So how about okay, we'll just keep each box 1, okay? So negative 2 will be 1/4, so it will be here. Negative 1 will be half, so it will be in the middle. 0 is 1. 1 is 2. 2 is 4. Right? If I do even more, right? 3 will be 8. 5, 6, 7, 8. So the graph will go like this way. Rising up very quickly, right? As we go to the right side. And then to the left side, it's getting smaller, but then it's never going to be negative, right? Because the base is a 2. So it's impossible to be negative. It will just get smaller and smaller. Okay, so it's approaching the x-axis. So on the x-axis, I would like you to draw dotted line. That line is called the asymptote line. Okay, asymptote line means the line where the graph is getting closer to. Okay, kind of like an invisible wall. Okay, it cannot go through. All right, so let's go to the other side. Same thing, we're gonna use the same points. Okay, same x values. So please raise your hand if you finish the table. Cindy, Samantha, Ray, have you finished the table yet? Yeah. Okay. So Tiana, can you tell me your y values for this one?
4, 2, 1, 1/2, 1/4.
Yep. Okay. So let's plot them out. Negative 2 will be 4. Negative 1 is 2. 0, 1. 1 is half. And 1/4. Okay. Sort of like going the opposite way, right? So instead of going up, it will be going down. So something like this. As we move to the right, it's getting smaller and smaller. Right? And once again, it never touches the x-axis. So x-axis, this line, right? X-axis is the asymptote line. So we use the dotted line. All right, so we have two kinds of graph, right? One is getting bigger, one is getting smaller. So when base is greater than 1, they will all behave similar, okay? Just that if, for example, if you try 3, if the base is 3, it will also be getting higher, but it will be getting higher faster, right? Because the base is bigger, okay? So on the top, now we can fill that in, okay? When base greater than 1, the function is increasing, right? Because it gets higher, okay? You can draw an arrow like that, increasing. And then the other one, base between 0 and 1, the function will be decreasing. So it'll be going this way, okay? Do not draw like that, okay? So it's decreasing. So you have asymptote line, right? Asymptote line, okay? Now let's take a look, okay? What other ways can you describe what happened to the second graph? How do you make the first graph become second graph? Using transformation. RST, which one will make the first one become the second one? Anyone?
Reflect over y.
Yep, reflection over y. Very good. Okay, so let's write that over here. Reflection. Actually, let's not put it there. Okay, this one. Reflection over y-axis. If you remember from the story, right? If I want to have reflection over y-axis, then we should have a negative on which variable? Cindy, do you remember? Reflection over y-axis.
X.
Yes, negative should be with the x, right? Then reflect over y. So that's what this arrow is talking about. This arrow is saying that I can rewrite 1/2 as 2 to the negative 1. Okay, let me write it again. Right, 1/2 is the same as 2 to the negative 1, right? And then outside you have an x, so 2 to the negative x. So if you look at this form, right, and the original one, right, is having an extra negative on the x. So that's a different way to look at the graph, okay? There's a reflection. All right, so when you get a question, you always identify whether the function is increasing or decreasing. And then you think about what kind of story is being applied, right? So if you see a question like this one, y equal to a negative x. So because the base is bigger than 1, then you will start with the increasing one. Okay, and then there's a negative, so you know it's making the increasing flip over over y-axis. Okay, so you look at the base first. All right, so let's look at a couple things here. First one is equation of asymptote, the dashed line, the dotted line. Okay, the equation for this one, because the every single dot, right, for the asymptote is always on the x-axis. So every point on there, the y is always 0, right? If you pick any point, right, the y is always staying at 0. So we call that equation y equals 0. Okay, the whole line has y value of 0. And then domain, what's the domain for both of the graph? What do you think? Eric, what's the domain for the two graphs?
Is it all real numbers?
Yeah, that's right, right? You can see from the graph, it keeps on going to the right and keeps going to the left, right? It never stops, right? So I can say X, E, R, right? Real numbers. What about the range? Donna, what's the range?
Y is greater than 0.
Yeah, okay, so it does not touch equal, right? Does not touch the x-axis, so it cannot equal to 0, right? Because when it equals to 0, that's the asymptote, right? Y equal to 0 is asymptote. Okay, x-intercept. Kelly, what's the x-intercept? Do you know the meaning of x-intercept?
No.
Okay, Cindy, can you tell us what's the meaning of x-intercept?
The point where it passes the x, the x-axis.
Okay, the point where the graph passes the x-axis, right? Yeah, so Kelly, do you understand the meaning of x-intercept now?
Sure.
You're sure? Okay. So what do you think? Where is the x-intercept then? Where does the graph pass through the x-axis?
But it doesn't pass through the x-axis.
So that means there is,
No solution.
yeah, so there's no x-intercept, right? You need to be able to identify, right? There's no x-intercept. What about y-intercept then? Can you tell me too?
1.
Yeah, so you can say y equal to 1, okay? It passes through this point. So it doesn't matter if it's increasing or decreasing, right? It's always at y equal to 1, okay? So these are the basic forms. So on the next page, we are going to apply transformation, okay? So when you see a question, first thing you need to check is whether it's increasing or decreasing, okay? And then start from there. So let's take a look at a simple question first. So question 4, here we want to sketch, right? So first thing you want to draw the sketch. Second thing, using the sketch, we want to answer the domain, range, asymptotes, right? Y-intercept, right? So total of 5 things to write it out, right? So look at this one. Is this graph increasing or decreasing? What do you guys think? If you think is increasing, then raise your hand. If you think it's decreasing, don't raise your hand. So the rest of you think it's decreasing? So Donna, how do you know it's increasing?
Doesn't have reflect over y-axis.
Say that again.
Doesn't have reflect over y-axis.
Reflect over y-axis. Well, to check increasing, decreasing, it's very easy. You don't need to think about reflection. You just check the what?
The 3.
The 3, yeah, that's all you need to do, okay? You just look for the base. The base here is a 3, right? And you know that one is bigger than 1, so you know it came from increasing, okay? You can draw this on the side, right? The original is this one, y equals 3 to the x. So since it's increasing, then we can draw the shape, right? So this is the basic. Okay, so it starts from there and then add the ingredients, right? It has an x plus 2 and the minus 4. So plus 2 and minus 4, what kind of story happened? Cindy, what does plus 2 and minus 4 do to the graph?
I'm not sure.
Okay, anyone knows? Plus 2, right? X plus 2, and then there's a minus 4 at the back.
Left 2.
And
down 4.
Down 4, yeah, okay. It has to do with translation, okay? So that's why I said the transformation is very important. It can be applied in the later chapters, right? Or, right here, we can review a little bit. We can change this to story form, right? Y plus 4, 3 to the x plus 2, right? Remember, if you have adding, it means going left or down, right? If it's subtracting, then it'll be right or up. So this one is both adding, right? So we have moving to the left. Okay, we can write this down. Left 2, down 4. Okay, so we need to apply this story to the basic. Okay, and to draw the basic, we don't want to draw all the points, right? Remember, we had 5 points. We don't need to do all that. We just need to get the important information. So one of the important thing is the y-intercept. Okay, that point, that y-intercept. And then another important thing is the asymptote line. Okay, so we want to apply the story to the y-intercept and the asymptote line. So let's do that. So used to be 0, 1. After the story, right after left 2, down 4, where is the new point? Where does that point go? Eric?
-2, -3.
Yeah, it will go to -2, -3, right? Left means subtract, right? Because you want to go left, you have to subtract the value. Down, also subtracting. Okay, so you know that red dot has moved, right? So let's plot that out. -2, 1, 2, 3. So it'll be here. Okay, and that's the only story that happened. Now, what about the green line, the asymptote line? Left 2 and down 4. Which one affects the asymptote line? Tiana? Which one do you think will affect the asymptote? Is it moving left 2 or down 4?
Moving left.
Moving left 2. So for example, here's the line, right? This is the original line. If I move this line to the left by 2, do you think it's a new place? All right, this line, this green line, the x-axis. If I move the whole x-axis to the left by 2, would that look different?
Yeah.
Okay, so moving left or right, it doesn't matter. It's still at the same place, right? So which one will make it look different?
Down.
Yes, okay. So if I shift the whole line down, then it will look different. Okay, we need to move it down by 4. Okay, so let's erase all the green dots. Okay, so we need to move the whole green line down by 4. 1, 2, 3, 4. So it will be at -4 there, and then we draw the line. Okay, so for asymptote, only up and down can affect the line. Okay, affect the location of the asymptote. And then since there's no reflection, right? There's no negative with the x or with the y. So it's still staying increasing. Okay, so it will just have the point going up, increasing. Now it looks like it's going to cross the y-axis, right? So before we move on, we need to find the y-intercept. Okay, so let's write that down, y-intercept. For y-intercept, which value should be 0? Cindy?
X.
X should be 0, right? So we'll sub 0 into the function that we have. Okay, so everybody please sub it in. Raise your hand if you find an answer, okay, for the y-intercept. All right, so Ray, what's your y-intercept?
5.
5, okay. Yeah. So I will put 1, 2, 3, 4, 5. So make sure it goes through the right place. So it'll be going up, right? And then crossing the y-intercept, increasing. Okay, so there is your graph. So we have our sketch, right? Sketch is here, number 1. We have our y-intercept, right? That's number 5. Okay, we still need to answer the domain, right? Domain, the range, right? And then also the asymptote. Okay, what's the domain? Kelly?
All real numbers.
Yep. So you can memorize this one. For exponential, it's always all real number. And range? What's the range now? Tiana?
Is it greater than -4?
Yeah, very good. Okay, greater than -4. So it changes depending on the graph, right? So you can also think about if we don't have the graph, right? If you just have the function, right? Is it possible to look at the function and then determine the range? Okay, what's affecting the range, right? -4 is this one, right? So has to do with moving up and down, right? So that way in the future, right, you can look at that, right? Make some guess first and then draw it out to confirm your answer. Okay, number 4 is the asymptote. What's the equation of the new asymptote right now? Kelly?
Y equals -4.
Yeah, okay, y equal to -4. Used to be, right, if you remember, you can look back, used to be y equals 0, right? And because it's moved down 4, right, it becomes y equal -4. So it all came from the basic. Okay, so let's try 2 more questions, okay? And then we're gonna move on to word problem, okay, applications. So please do question B, okay, by yourself. Okay, but before we begin, okay, let's double check the base. We have 2 numbers here, right? There's a 4 or a -4, okay? If you think the base is -4, please raise your hand. If you think the base is 4, don't raise your hand. What's the base? Okay, so nobody raise your hand, right? So the base is 4, okay? So you have to think about the basic, it came from this one. Okay, so do the same thing by yourself. This one is still the came from the increasing one, right? Because base is 4, bigger than 1. And then from there, think about the story. Once you get a story, you get a point, get the asymptote location, okay? And then you can start answering the 5 things. Okay, so if you finish this question, you can raise your hand. Okay, just question B for now. Okay, let's double check with what story you got, okay? What should we apply to the basic? Let's talk about RST here. Do we have reflections, Cindy?
Yes.
Okay, what kind of reflection?
Reflect over y and x.
Okay, so two reflections, huh? Okay, over y and x axis. Okay, so you need to think about what it should look like after the two reflection, right? That will determine the way you bend the curve. Okay, you can draw a little comic strip, right? If you remember, we can draw how it changed after each reflection. What about S? Stretching, shrinking. Do we have anything about stretching or shrinking? Donna?
No.
Okay, this one is none. Okay, to tell whether you have it or not, you look at whether there's a number multiplying with x or anything that's multiplying with 4, right? Or anything that can be moved under the y, right? Okay, translation. What kind of translation do we have? Left, right, up, down. Kelly, what do you think? What translation do we have?
Down 1.
Yep, down 1. Very good. Okay, so please apply that to the point. Okay, and then continue. Also, you need to get the new place for asymptote, draw the graph. And before you draw the graph, right, if there's y-intercept, you can find it first. If you think there's no y-intercept, then you can say none, okay? So Ray, where is the new location for 0, 1? Where would it go?
Oh, 0, 0.
0, 0? Is that what you said? 0, 0?
Yeah, I guess.
Okay. Anyone else? Anyone got different location for the 0, 1?
Got -1, -1.
-1, -1. Anyone else got different?
I got 0, -2.
0, -2. Okay, so this is very important, okay? The location of that point. Anyone else got different? Kelly, what do you have?
I have 0, 0.
0, 0. Donna?
0, -2.
0, -2. Tiana?
0, 0.
0, 0. Okay, so let's check, okay? See which one works. Remember to find points, right? You got to go in order, right? Start with R and then S and then T, okay? If you have reflection with X and Y axis, then you make, okay, I'll move the points away first. You'll make each of the X and Y change sign, right? Multiply by negative. reflection over y, then you make x negative, but x is 0, right? 0 times negative is still 0, so it'll stay the same. And then reflect over x-axis, you will make the y negative, so it'll be negative 1. Okay? And then after that, there's no stretching, so nothing to multiply with, right? And then you just move down. Move down by 2, it will affect the y value. So 0 will stay the same. Negative 1 has to go down by 1, so you should go to negative 2. Okay, so your point you should have should be negative 2. Okay, so make sure you fix that. Because that is going to affect your graph for sure, right? 0, negative 2. So we have a point there. Next thing is we need to know where the the asymptote, right? The horizontal asymptote. What's the equation for that? Where's the new asymptote place? Donna, what's your new asymptote?
-1.
-1, okay. So let's put that there. Right? It came from our experience before, remember? We had -4, which is the moving down -4, right? You can see how you can get it without a graph, right? So you have a -1 moving down, so your asymptote will be at y equal -1. Okay, so let's draw that out. Y equal to -1. Okay, now the y-intercept is the same place, right? 0, -2, so we don't need to find y-intercept. So that one is already found. Y-intercept, our number 5, is 0, -2. Okay, 2 and 3 is the domain range. So you need to see the graph to answer that. Okay, if you finish the graph, please raise your hand.
Wait, is the asymptote just do you just take that second number?
Now you take the moving up and down, the translation, you use the translation. If it's
Okay.
moving down, it will be -1. If it's moving up 1, it will be +1.
Okay.
Yeah. Because everything else, it won't affect the asymptote, right? Because it's used to be y equal to 0, right? Even you multiply by negative, right? Reflection, it still stays at 0. Even if you stretch it, right? 0 times anything, it's still gonna stay 0. So the only thing that can affect a 0 is by adding or subtracting the number. Okay, complete the graph, okay, draw the shape, think about which direction it goes. Right now, all you have is a point and the asymptote line. So how do you curve it? Okay, draw the graph and raise your hand. All right, so let's check, okay, see if you guys got the same curvy, okay? So we have couple reflection here, right? Reflection over y-axis. Oops, wrong equation. For y-axis will be -x, right? So reflect over will look like that, right? And then there's another reflection, right? Put another negative. That will be reflecting over x-axis. So flip down, right? So your graph is curving this way. Okay, so I hope you guys got the same curve. So what will be the domain? Well, domain, we already know. Domain is always a real number, right, for exponential. So what's the range then? Kelly, what's the range?
Y is less than -1.
Yeah, y less than -1. Okay, so you could also see if there's a connection with the original function with the range, right? You can see -1 is moving down. And this time, instead of greater than, we have less than, right? And the reason for that is there's a negative in front, right? Reflected over x-axis. This negative at the front will make it flip over, become less than, okay? So think about the reason why it works like that. So sometimes maybe you don't need to graph it out all the time, right? You can just tell from the function. Okay, question C has a base of 1/4. Okay, so basically it starts with y equal to 1/4 to the x. So that one is the decreasing one. Okay, so I will leave that this kind of question as homework. Okay, and you can try that. Okay, so you start with decreasing, and then you can apply the story to it. Okay, or maybe we can go over this one next class too. Let's look at the word problem. Okay, I want to go over at least one type. So this type is called the compound interest. Okay, different from simple interest. Simple interest is every time when you get the interest, the amount is always the same. Okay, interest is the money the bank will give you. Okay, when you deposit your money into their bank, right? Just to, because when you deposit the money, it's like you are lending the bank your money, and they can take your money to do whatever they want. Okay, they can probably buy a property, right, and then sell it, and they can make money, and then they share what they earn with you guys, right? And that's called the interest. Okay, so you have two kinds of interest. One is called simple interest. So every time usually you get it once a month, or sometimes they give it to you once every year, right? Depending on the contract you sign with them. So simple interest is every time you get the same amount, always, let's say $10 each time. But compound interest is building up. Okay, your money will increase each time. The interest is depending on how much money, the new amount, including the interest that you get. Okay, it may sound confusing right now. Let's use an example then. So here we have a table. Okay, the table, the A0, A represent the amount. Okay, total amount. The 0, 1, 2, those are the year. Okay, and then the one more column is number of time interest is calculated per year. Okay, it's talking about each year. So the example here we have is amount of 1,500, okay, saving, and then he is earning 6.5% per annum, means per year, compounded annually. Okay, this is saying that they give you the interest once every year. Okay, they calculate the interest once a year. Okay, compound annually. Derive an exponential function, right, for the total amount. So we want to find the total amount of money after t years. Okay, so we'll start with 0. 0 years means at the very beginning. Okay, the money you just deposit. Okay, so that will be beginning, right? You haven't earned any interest yet. So number of time is 0. Okay, and then A of 0 will be 1,500 because you just put the money in. Okay, and then after 1 year, how do I know what's the total amount that we get? I leave the money inside the bank for 1 year. How do I know how much money I have? Eric, how do we calculate that?
Multiply it by 1.065.
Yeah, very good. Okay, let's break it down a little bit slower. Okay, so I will have to get the interest amount. You can take the 1500 multiplied by the interest rate 0.065, and that's the interest part, and you add it with the original. Okay, and then you can factor out the 1500. That will give you 1 plus 0.065. Okay, so 1 plus 0.065, that's where the 1.065 come from. Okay, so the 1 includes the original amount. Okay, so you're adding, so at the end, the money you have, it will include the 1500 and the interest together. Okay, so because it's annually, so the number of time interest is calculated is only once. Make sense? Okay, now for the second year, because it's compound interest, so we are going to take what you have in year 1. Okay, when you see A bracket 1, this is not A times 1. This means the amount after 1 year. Okay, so this is one thing, one item. Okay, amount after 1 year. So the next one is amount after 2 years. So to figure that out, we take what you have before, the year before. You don't use the 1500 anymore. Okay, so you do the same thing as the previous box, but instead of 1500, we are going to use amount after 1 year. Add it with amount after 1 year times 0.065. Okay, you see I'm doing the same thing. Okay, but then the money that you put it in is bigger now, right? Because you already got some interest inside. And then we do the same thing. We are going to factor out amount after 1 year and then multiply by 1 plus 0.065. Can you raise your hand if you follow up to here? Anyone has questions? Okay, how we get here so far?
I don't get why the 1 plus 0.065.
Does which box? This box or
Yeah.
the next box? The first box?
Yeah.
Yeah, okay. What we did is I factored it out like GCF. You have 1500, you have 1500 as well, right? So I factored the 1500 outside.
But then, what? Oh, okay, yeah.
Right? So if you multiply in, right? Multiply back in, you get the same thing back. Make sense?
Yeah.
Yeah.
Okay.
Okay. So all I did is factoring. So same with the next box. I have A1, so I factor out the A of 1, amount after 1 year.
Okay.
Got it?
Yeah.
Okay. So after this, because A1 is actually 1500 times 1 plus 0.065, right? So I'm going to replace A1 with 1500 1 plus 0.065. This part is A1 times 1 plus 0.065. Oops, wrong circle. The thing I'm circle is A1. I'm just reusing our second box, right, the box above, to replace A1. You get it? Can you raise your hand again if you understand what's going on? Okay, I'm just replacing A1 with what we got on the last box. Now, as you can see, the two brackets has the same, right? They both have 1 plus 0.065, right? So they can multiply and then write it as 1500 1 plus 0.065 squared. Okay? So 2 years, you calculate the interest 2 times, so the money will be 1,500, 1 plus 0.065 to the 2. So if it's t years later, right, amount after t years. Okay, let's write that in sentence. Amount after t years. Then it will equal to, in this case, is 1,500, right? That's the amount of money that you put in. 1 plus the interest rate to the t. Right? If it's 2 years, it will be 2. Right? Look at the yellow highlighted. Right? 2 years will be 2. 1 year will be 1. Right? It's only 1. Right? So if it's t years, will be t. Okay? So you can use this formula to find the money after any years you want. Okay? So here I would like you to take out your calculator. Please find the money after 20 years. So A of 20. Okay? So please write it out first, put it into the formula, and then type it into your calculator. Raise your hand, okay, once you got the answer. Okay, so the thing that you need to type in, you start with 1,500, right? 1.065 to the 20, okay? Make sure you have brackets, okay? So, Cindy, what's the total amount you have?
5,285.47.
Yeah, very good, okay? This is money, so you will round it to the cents, okay? 47 cents, okay? Anyone got different? Okay, so this is for annually. Okay, annually means you get interest once a year, but sometimes they give you interest like once every month. Okay, so you get more frequently. Okay, so this the example we have here is kind of like the New Year red pocket, right? You only get it once a year, and then if they give you more frequently, so it's more like pocket money, right? Maybe your allowance, right? You get it once every month, right? Or once every half year, right? Whatever. Yeah. So more frequent. So let's look at an example here. You start with 1,500 again, okay? Let's try to keep it simple, right? Same amount to start. So initial, right, will be 0 times. Amount at 0 year is 1,500 because there's no interest yet. Okay, interest rate I'm keeping the same as well, but this time the interest is semi-annually, right? Compound is semi-annually. This means twice per year, right? Semi means half, right? Half year. Semi-annual, right? Half year. So you every half year you get an interest, right? They give you some amount, okay? So you get 2 times more, right? Instead of once a year, you get 2 times a year. And then we're going to derive the formula again, okay? So same thing is gonna happen, right? 1 year later, how many times have you got the interest? Tiana, what do you think? After 1 year, how many times did you get the interest?
2.
Yeah, you'll get 2 times, right? Because this time is semi-annually. So 6 months later, you get 1, 12 months, right? Another 6 months, you get another interest, so 2 times. So the amount, right, if you look at the table above, it's going to do the same thing, right? 1,500, right? And then let's skip to the final look, right? Because we know it's going to be factored out. So it'll be 1,500, 1 plus 0.065. And because it's 2 times, it will be squared instead of 1. Okay? But it won't be fair for the bank, right? Otherwise, everybody will be choosing this way. Of course, you want to get the interest more frequently, right? So you get the interest more frequent, but then the bank is not gonna give you so much interest. Otherwise, they will go bankrupt, right? So even though they give you more frequently, they will cut the interest rate in half. Okay, so each time you get less, but then you get it more often. Make sense? So kind of balance out, right? You have a lower interest rate, even though the interest rate they give you is for annually, but every 6 months, you get half the interest and you get it 2 times. You get it so far? Can you raise your hand if you understand what I was talking about? Okay. You have low interest rate, but you get it more often. Okay. So this is for 2, right? Now let's do the same thing. So this will turn out to be some amount. Now for 2 years later, how many times have you got the interest now? Ray?
4.
Yeah, it will still be 4, okay? It will be 2 times, right? Two times a year, so 2 years will be 4 times. So we are going to take the original amount from the previous year, right, to continue, right? So it will be A1 as the beginning, right? And then take that, do the same thing, 0.065. We cut the interest rate in half. Well, they cut it, now you cut it, right? They cut it in half, and then you do 2 times, right? You apply this to the amount that you got after 1 year. And this amount is what you got from above. Okay, so I'm going to do the same thing. Replace what you got after year 1 with A1. So it'll be 1,500. 1 plus 0.065 over 2 squared. This is amount after 1 year. Right? Look at the red circle. It's the red circle. 1 plus 0.065 over 2 squared. So this will end up to 1,500. 1 plus 0.065 over 2. Now to the 4. Okay, do you follow up to here? Can you raise your hand if you understand where that comes from? Or if you have question, you can ask me now, right? Any step you got lost? Okay, basically I'm doing the same thing. The only difference that has happened is the interest rate got cut in half. And also the number of times you get the interest is increased, right? So you can look at the yellow highlighted. 1 year, you get 2 times. 2 years, you get 4 times, right? And then you got an extra cut in half because of semi-annually. Then you need to cut in half. Okay, now we need a formula then. Okay, if it's T years, how many times in total then? How many times do you get the interest then? Cindy, what do you think? What do we put here?
2t.
Yeah, very good. Okay, you just multiply by 2, right? So this will be 2t. Okay. So if we write out the formula here, it will be 1,500, 1 plus 0.065 over 2, right? Because semi-annually, and then 2t is like the exponent that you will use, right? So 2t will go here. So 2t is the exponent. The extra divided by 2 is semi-annually. Okay, so now I would like you to try calculate for 20 years again. Everything else is the same, but the only difference is semi-annually. Let's see if the amount will be very different. Okay, so please type it into your calculator and raise your hand after you get it. Okay, so if we type it in, it will be 1500, 1 plus 0.065 over 2 to the 20 years, so we should put 40 then, right? Okay, what's the final number, Eric?
5,391 and 30 cents.
30 cents, okay? And E-Ray, do you have the same?
Yeah.
Okay, so these two are a little bit, right? A little bit bigger. This one is a little bit more money than the annual one, okay? So let's make a conclusion on the top now, okay? We'll put the money, put the formula, okay? In the formula box on the top. So the 1500 is the initial amount, okay? So, or you can call that the principal amount. So let's put it in the formula now. So amount after t years, it will equal to the principal amount multiplied by 1 plus interest rate divided by n, and then n times t. Take a look at what we have at the bottom. Okay, let's write down what each one means. This is amount after t years. Okay, the first part. And then the P is the principal amount, or the amount you deposit, okay? The amount you put it into the bank, okay? The 1500. And then the I is the interest rate. Okay, make sure it's in decimal. And T, of course, is the time, right? The time that you put the money inside. And finally, the N, right? The N that you have here, both N represent the same thing, right? Is the number of, okay, this part is difficult to write. Let's write it, okay. Number of compound period per year. What does compound period means? Compound period means the time that you get the interest. For example, annually. Annually means 1 year, right? So how many 1 year each year? So only 1 year. For this one, right, semi-annually means your compound period is half year. So how many half year per year? Each year you have 2 half years, so that's why n equal to 2. Okay, so you have couple terms here. So we need to write that down, okay? So for example, you get annually, n is 1. Semi-annually, n is 2, okay? We have like quarterly. Quarterly means every 3 months. Okay, 3 months is your compounding period. So how many 3 months per year? Cindy? How many 3 months in a year?
4.
Yeah, so n will be 4. Okay, so that's how you figure out the compounding the n. Okay, and then monthly. Right, monthly will be every month, right? So there are 12 months a year, so n will be 12. Okay, so depending on the question, they can say daily, right? Then you can use 365. Okay, but I think these ones are enough to use. Okay, so that will be it. Just make sure you know what number to put inside each one, and I'll give you a couple practice for homework for this. Okay, if you have any question, you can stay after class. Otherwise, I'll see you next week. Okay,
Bye bye.
bye bye, bye Donna,
Bye.
Hi.
bye everyone. Have a good
Bye.
weekend.